Hello everyone, welcome to our lecture 10 of programming with C++. So today we are going to learn about operator overloading and then derived classes. So by the end of this lecture, you'll understand what operator overloading is and then how to use it. Learn about derived classes and how they work. Master the concept of inheritance and its different types. Understand polymorphism and how it makes your code more flexible. So let's move on to operator overloading. So let's start. This is this is really cool feature that allows us to define how operator works with custom classes. So operator overloading lets you define exactly what happens when you use operators like the addition, subtraction, multiplication, and then division, and then the the increase and then the decrease operators. Okay, so uh, let's so the plus operator here, when you use these values of type int, returns their sum. But however, when used with objects of a user-defined type, it is an error. Okay, so let's visit operators. Before we dive deeper, okay, let's visit them. So arithmetic operators are the addition, the subtraction, the multiplication, division, and then the modulo. And then the logical operators are the ampersand. That's the logical operators. Okay. And then the or. And then we have the relational operators. That's the increase and then it's not equal to. And then less than or equal to or greater than or equal to. And then we have the pointers, that's the ampersand and then the asterisk. Okay. And then we have the memory management operator, new or delete, and then you bring your bracket. So the types of operator overloading, we have the function overloading, and then we also have the operator overloading. So this is the syntax for operator overloading. So you bring your return type, your operator, that's the symbol, okay, and then you bring your parentheses and parameters. Bring your parameters and then inside your parentheses, and then you bring your curly braces. So let's break this down. Okay, so the return type, this return type means the exact type of value the operator returns. Okay, that's the return type. And then operator is a special keyword that tells C++ we are overloading an operator. Okay, and then we have the symbols. The symbols is the actual operator we want to overload. That's symbols like the plus, the increment, and then the subtraction, the less than, and then you can mention them. And then the parameters are overloaded operator that you'll be working with. Okay. So this is how it's going to be like. So you bring your data type, that's the int. You can use any type of data type. Okay. Then you bring your operator and then you bring your symbol. and then you bring your parameter inside the bracket, and then you open your parentheses, you return, bring your return type. So let's look at some rules you cannot apply when using operators. Okay, operator overloading. So we have the terminary or the conditional operator. That's the question mark and then the column. And then scope resolution operator. That's the double colon. Dot operator or member selector. That's the dot. Pointer member and pointer to member operator. That's the dot asterisk. And then object type operator. That is the type grid. And then object size operator. That's the size of. So these are the rules you shouldn't be using when using the operator overloading. And then you should know that only existing operators can be overloaded, and then new operators cannot be created. Only built-in operators can be overloaded. And then existing operators cannot be renamed. At least one of the operands is overloaded, and in overloaded operator must be user-defined. Let's look at some advantage of the operator overloading. So we have one, the simplified syntax. So the simplified syntax is your code. It's when your code becomes more readable and then intuitive. Okay, instead of writing, let's say point one, add point two, you can write point one and then plus point two to make it readable and then intuitive. And then consistency. So the consistency here is when your custom classes can behave like built-in types and then making them easier to use. Okay, and then easier to understand. Using familiar operators makes your code more intuitive for other programmers. As in, you've programmed a code in your company and then now a time come that you left the company and then another programmer comes to take charge of your code that you've programmed. It will be very easy to be understood by the new programmer. Okay, so it makes it easier to understand. And then the disadvantages of operator overloading. So far as we have the advantages, definitely we must have the disadvantages. So let's check out the disadvantages of the operator overloading. So one, we have the potential misuse. Here, it means like if you miss overload, if if you overload operators in unexpected ways, it can confuse other programmers. As I said earlier on, it wouldn't be readable and then so confusing. And then complexity. The complexity here is when it's let's say when you are overusing operator overloading, it can make your code harder to understand. It becomes complex. And then limited overloading. Not all operators can be overloaded, as we saw earlier on. And then derived classes. This is where things get really interesting. Okay. So a derived class is a class that's created from an existing class. So we derived something from the base class. Okay. So when you derive something, if something is not in an existence, you can't derive it. You can't derive something from it. Okay. So this so here you can have a general vehicle class. Okay. You might create more specific classes like motorcycle, cars, and then so on and so forth. So the original class is called the base class, and then or the parent class, and then the derived class is the child class, as we saw in lesson um lesson 9, lecture 9. Yes. So let's move on to the derived class definition. So the derived class definition here is where the derived class definition, it begins with the keyword class followed by the derived class name and then colon followed by the access specifier. We've seen the access specifier and then the base class name structure. So this is the structure or the syntax for the derived class definition. So we've seen this already. Then this is the sample code for derived class definition. Now let's look at derived class using access modifier. So the derived class using access modifier is when creating derived classes. Like you can control how the base class members are inherited using the access modifier. Okay, so the access modifier, as I said earlier on, is the public, the private, and then the protected. And then this is the syntax for the access modifier. Okay, so the derived class using access modifier. So the public, if a derived class is declared in a public access, then the members of the base class are inherited by the derived class just as they are. They do not change. Okay. So the private, if a derived class is declared in private access, then all members of the base class become private members in the derived class. As I said earlier, if something is private, not we have some specific people who can get access to it, and they're protected too. The public members of the base class become protected members in the derived class. Okay, so the private members of the base class are always private in the derived class. And then this is the syntax for the modifiers, okay, the specifiers. We looked at inheritance in our previous lesson, so okay, so let's look at the flow process of inheritance. So this is the base class or the parent class, and then this one is the derived class or the child class. So animals here, the base class, animals in general, okay. So a dog is an animal, okay. So this class is derived from this. This dog is derived from this animal because this is the general one, and then this dog too is being derived from the animal. And then this is the source code for inheritance. So you can try your hands on. And then we have the 5 types of inheritance. So one, we have the single inheritance. With a single inheritance is the simplest form. So one derived class inherits from the from one base class. And then we have the multi-level inheritance, we have the multiple inheritance, the hierarchical inheritance, the hybrid inheritance. So let's look at them one after the other. So this is the single inheritance. So the single inheritance, this is the base class or the parent class. This one is the derived class or the child class. So vehicle in general, we can derive a car from vehicle. We can also derive motorcycles from vehicle. But here it's just a single inheritance. So it can either be just a car or a motorcycle. Okay, so this is inheriting from this base class. And then the multiple base and the multiple inheritance is derived, it's a derived class, inherits from multiple base class. So we can see the multiple base class here. So land vehicle, and then the water vehicle. So we get amphibians vehicle. So when we say amphibian, they are they are let's say they can both live on land or in water. So we are using vehicle for the base classes. So the land vehicle and then the water vehicle we get the amphibians. Okay, they can belong to this or they can also belong to this. So they are derived from this. They are at the same time derived from this. So that's the multiple inheritance. Then the multi-level inheritance. With the multi-level inheritance is derived class is when a derived class is inherited from multiple base classes. So we have the multiple base class. So we have the one and then we have the two. So this is inherited from this two with this. And then we have the hierarchical inheritance. So with the hierarchical inheritance, multiple derived classes inherit from the same base class. So we have the multiple derived classes here. So we have the car, we have the class car, we have the class bus. We can also have class vehicle, sorry, class motorcycle or class truck here, all deriving from just single um class. Moving on to the hybrid. So the hybrid contains and this combines multiple types of inheritance. Okay, so yeah, we can see we have the single inheritance. So this is the single inheritance because this is inheriting from this only. And then we have the multiple inheritance. The multiple inheritance too. We can see the class and then the class bus and then the car inheriting from this base class. And then we also have the multi-level. So we have the single and then we have um, the multiple and then we also have the um, multi-level um, deriving from this. So let's see the rules for inheritance. So we have the static members. So they are class dependent and then are not inheritable. Friends classes are not inheritable, and then constructors and destructors too are not inheritable. Okay, so you being my friend, you can't inherit from my father or mother. Okay, you can't inherit from my family. You are just my friend. You are not part of my family. So you can't inherit from my family. So they are not inheritable. And then polymorphism. We learned polymorphism in our previous lectures. And then a source code for polymorphism you can try your hands on. And then we have our tags.